students that embark in exercise science or kinesiology in general, like they have an interest, at least we hope, because they like to move and they like to exercise and they like to improve their performance, former athletes, that sort of thing. So for me, the only way I can truly reach my students is if I tap into their own relationships and influences in regards to how they move. Because if you only present the science without any context, then at least in my experience, it just goes over. It doesn't land at all. It doesn't land at all.
As a student, talking to your professor or older grad student, learning from them, hearing about their stuff, what they're working on, learning from them. And then now as a faculty member, like my favorite thing is when I got students coming in office hours that are asking questions, not just about the stuff that we covered in class, but like outside of class, how does this relate to the real world? And what about this? And what about that? Like, that's sort of my favorite thing. All right, welcome to 30-Minute Physiology. I'm talking with someone who I have been looking forward to the chance to talk to for a little while. Sorry, not my bad, not doctor. Not yet.
Almost.
Okay.
We're good.
Soon to be Dr. Jonathan Beausejour. I get that?
Perfect.
Okay. All right. Jonathan, thanks for taking time to talk with me. I've been looking forward to it. Like I told you, the first time I came across you was at ISSN, International Society of Sports Nutrition Conference in 23. You were presenting some data. I'm not a neuromuscular guy, but thought it was interesting data. I really liked your presentation. And so when I, got the idea to start doing this thing here, you're one of the guys that I want to talk to. So appreciate the time. Appreciate you meeting over Zoom and looking forward to the conversation. So how are you doing today?
I'm all good, Dr. Escobar. I appreciate the invitation and the opportunity for me to hop on your podcast and talk everything neuromuscular and beyond. I'm doing pretty well. I'm in PA right now, so not in sunny Orlando, Florida. Nice change of weather here. Hurricane Debbie got me out, but it's all good. And yeah, I'm feeling good, ready to go.
All right. You can call me Kurt. Doctor is, formalities. Appreciate that, respect. But we're peers. So yeah, man, I'm always interested in figuring out and hearing about how people got interested in the area of exercise science. Yours is a real different area than my sort of sub area. Obviously took classes and learned about some of that stuff, but never really got into like the hardcore details and heavy studying like you are doing right now during your PhD. But I just want to hear about how you got into that. And as we were talking before, and I came across this when I was, looking you up, was you were a hooper. And that sort of informed, or at least led, or sort of overlapped with your interest in exercise science. So why don't you talk us through, how you got to where you are?
Yeah, man, you're exactly right. I'm a hooper, and I still have that hooper mentality with me. I got interested in the field of exercise science primarily through my athletic background. I love basketball. I love college basketball, NBA. I'm a huge basketball fan in general. So
can I ask you a question? We just go straight to it.
Okay, what's up?
Okay. I'm from California, where I'm in Long Beach, near LA.
Right.
I didn't grow up down here. I grew up in the 90s. Michael Jordan was God.
Right.
He was on every wall of my room.
Put me on the spot already.
Jersey. I got 5 days a week, Chicago Bulls gear.
Right.
now we got next generation. We got Kobe.
Right.
And to be honest with you, I did not like Kobe because, he's the next Jordan. He's the next Jordan. It's like, nah, there
Right.
ain't never going to be no other Jordan. So I
Right.
was a Kobe hater for a while. But as I got older, watching him, man, this dude was a killer.
Killer, man.
And so now I'm a Kobe, big time Kobe fan.
Right.
Now we got the other guy.
James.
So I gotta ask, where are you putting him?
Like ranking them.
The other guy, just to clarify, the other guy meaning LeBron.
Right.
For those that may not know. Yeah.
Right.
Yeah.
Right. I'm biased, man. My I grew up watching 90s basketball, man. I was born in New York, so I'm a diehard Knicks fan. So for me, and mind you, I was born in 95, so like a lot of these points I've read up on, and being a diehard Knicks fan. And to be quite frank, we're coming up now, but there was a period, essentially most of my life, that there really wasn't much happiness to look forward to whenever NBA season came around. So with that being said, the person that always killed the Knicks was Michael Jordan. And, based off of what my family thinks and me growing up, and I don't consider myself an historian of the game, but I really do acknowledge and appreciate the individuals that came before. My GOAT is Michael Jordan. I don't think there's any discussion related to that, at least as far as impact and sheer dominance. Now, what LeBron James is doing right now is unprecedented. His longevity, his attention to detail, his IQ of the game for that long. It's a unique blend of physical attributes with the mental side, being able to think the game, and just discipline. You know what I mean? Like all that kind of wrapped into one. My GOAT, of course, is Michael Jordan. I think he played maybe 14 years. So comparing stats between Jordan and LeBron, you can't really do that because LeBron just has a lot more stats that he accumulated. But I'm biased, of course. The mentality, how you approach the game, being a killer, that's one of the notches for me. And there was a point where nobody was messing with Jordan. And even when Kobe came, Kobe had his reign in the league. Kobe was cut from that same cloth. Not exactly to the level of a Jordan, but when you talk about that killer mentality, and it's tough. It's tough to have that mentality. Like a lot of individuals aren't your friends. You know what I mean? So they coming out to the court ready to annihilate you. And even with all that being said, you still being able to dominate guys how Jordan and Kobe did is like, for me, that's just on a whole nother level. So that's my pick, man. Jordan's the GOAT, but if I'm being honest with you, I don't think we'll see another LeBron James either, if that makes sense. So
yeah, for sure. It's one of those things where you can't really go wrong.
You can't go wrong.
You know what I mean? Yeah. And I haven't really watched too much basketball, to be honest with you, as I got older. Revisiting it a little bit now. But yeah, for me, is Jordan, of course, objectively, but also because I'm a 90s baby.
Right.
So I tell my students, like, if I got to put it, and again, I'm not super well informed, right, and not super into it and breaking things down from a day-to-day, like game-to-game standpoint. But for me, I got to go Jordan 1 and then Kobe like a 1A.
Okay.
But that's just me. That's just me.
Right.
And I know what LeBron is doing ain't never been done before.
Right.
But I just found myself as a Kobe fan, especially living down here, man. There's murals of him all over the place,
Right.
Yeah.
Right.
Yeah.
Yeah. If I was living in California, like Southern California to be specific, my perspective may be different, because we're all kind of shaped on our our perspectives and beliefs. But for me, I think I'll go Jordan, I'll go LeBron, and then Kobe. So
You can't go wrong. Can't go
can't
wrong.
go wrong. Can't go wrong.
Yeah. Yeah. I always like watching those conversations with like ex NBA players, like going back and forth on this one. And
Yeah.
yeah. Okay. All right. Well, that was a nice little aside. But going back to you, yeah. How did you get to exercise science?
Yeah. So it was again like all through my athletic career playing basketball. Um, Interestingly enough, what eventually informed my work in the neuromuscular space is actually the institution that I attended during my undergrad, which was like a smaller school, NAIA Division One. I played there for 4 years. Pretty great competition, actually. But that school is primarily a chiropractic school. So when individuals think about, you know, chiropractic doctors and stuff, mainly they think about getting the adjustments, getting their bones realigned, um, basically more so related to uh, like orthopedic in nature, right? But being there for 4 years and speaking to different chiropractic students and chiropractic doctors, they said that their main job is to really influence the nervous system and how well the brain communicates with the peripheral muscles. And then I'm like, oh shoot, that's pretty interesting. Like I didn't really know that that was like a thing you can manipulate based off an adjustment. And this is not a shout out to chiropractic philosophy or whatever, but this is what got me interested in the brain's role in muscle function in general. So after that, I went to Auburn to complete my master's. A funny story behind that, I actually wasn't, supported financially in regards to working in a lab or something. Uh, I was still interested in the field, obviously, but I just didn't have that opportunity. So my concentration there was biomechanics, but that was by and large through like the classroom and just kind of helping out labs offline. Uh, and through my work there, I was able to get in contact with my current PI at UCF, who really specializes in neuromuscular physiology. And that's what took me down the path and I'm on now. And I'm happy to say that I've been a part of some great projects, and it really opened a door for me, at least in regards to the importance of the brain and how that influences functional outcomes, muscle performance in the context of strength, and how all that can lead to just a better quality of life for individuals who are not athletic or don't engage in like athletic pursuits, being an athlete, or potentially infusing those concepts in a way that can hopefully serve athletes down the line.
For sure, for sure. Yeah, man, you got some good pedigree, man. Auburn, Central Florida. Did you
Yeah.
work? I think you were on. At least I seen one paper
Yep.
with Mike Roberts. Did you work
Yep.
much with Mike Roberts?
Yeah. He's to be honest, man, he's the main reason why I'm in UCF right now. I took a couple of his grad courses. I tell you like a funny story about that, man. I had no idea like these big names in the field, like especially when I came to Auburn, had no idea. And this was immediately after COVID. So a lot of these classes had the options to deliver courses remotely or have them delivered in person. So the first class I had with Dr. Roberts, it was a nutrient timing class, and he mandated that the students come in person. And in my mind, I'm like, man, come on, it's COVID. I'm not really trying to go out there. I'm kind of comfortable in my situation. So like I didn't really understand why he was having us in person. But anyway, I go into the classroom and like he comes in and he just comes in chill, man. Like I don't want to put him out there like that, but he has like a t-shirt and some shorts on. He was like long hair. I'm looking at him. I'm like, oh, this is the dude that required students to come into class. So in my mind, I'm like, man. But once he started speaking, I'm like, oh, damn. Am I allowed to cuss? No cussing. No, no.
No, you're good. You're
Uh,
good.
yeah. I was like, man, this guy's brain is on a whole nother level. Um, so interestingly enough, he also taught the neuromuscular graduate section at Auburn. So I took his class and I kind of expressed my interest related to neuromuscular physiology and his previous work. And he was nice enough he was nice enough to allow me to hop on some of his projects, with his students. And I was just there again, not supported offline, just supporting some of their analytical work. I remember counting satellite cells after they did all the wet lab techniques and going through Imagery and all that stuff. But man, I can't really express uh, enough good things to say about Dr. Mike Roberts. Man, he's a fantastic scientist, but even a better person. So definitely, he's the reason why I'm here. Um, yeah, he's the reason why I'm here. I just leave it at that.
It's funny you described him walking in the classroom that way, because the first time I seen him at ISSN for like 2017 or something like that, when you know the name, read all the papers,
Yeah.
right? And it's interesting when you see the people for real in real life. Like, oh, that's so and so. Oh, that's so and so, right? But me and Dr. Van Dusseldorp, she was a former VP at ISSN.
Yeah,
We used to call him muscle physiology Jesus, because, like
yeah.
you say, he come in with a t-shirt, long hair, wearing the sandals. But yeah, no, he's one of those guys that's like very respected and incredible work.
No doubt, no doubt.
So you're at UCF now,
Yep.
and you're working with Dr. Matt Stock. Is that correct?
Yes, sir.
Okay. And the data that you presented at ISSN, was that from UCF or was that from Auburn?
Yeah, so that was actually a collaboration project. The data I presented was more so the neuromuscular analysis, and we can call it a secondary analysis that we did based off the parent project. And the parent project was actually ran by Dr. Bradley Ruppel, who's now at Utah, but he was a PhD student under Dr. Roberts at Auburn, and his that study was primarily investigating the uh, low resistance training and reserve, low RR training versus high RR training, and how that influences uh, muscle hypertrophy, how that influences strength gains or appreciations, both from an isometric perspective as well as a lift specific perspective. And that was that main idea. And my mentor, Dr. Stock, he pointed out that there may be a couple neuromuscular questions relative to fatigue that, we can also investigate with this product as well. So the data that I presented at ISSM was primarily like a secondary analysis, which is actually under review as of right now, round 2. So hopefully that will be out, available, published pretty soon. So
Nice. And what specifically? Just tell us a little bit about the results from that study.
yeah, from
And also related to that, and like we can touch on this like at a more broader standpoint as well. But what population
yeah,
were you working with? And then also, and we can talk about this a little bit later on too. If you're doing exercise research resistance training, interval training, whatever the case is, like there's the exercise itself as an intervention,
Right.
and then there's like who are you using it for? What is
Right.
the application?
Right.
Right? Is it therapeutic? Is it performance enhancement?
Right.
So there's a lot of different applications when we talk about exercise. So I think that's something that it looks like you're getting into, right? Looking at different populations. But
Yeah.
why don't you start first with the results from this study?
Yeah. Yeah. Sure. Sure. So the parent manuscript, I can call it, is available in physiological reports, and Dr. Ruppel, of course, is the first author in that investigation. The the sample population is just young, active adults that were previously trained. So these are not untrained individuals. They're familiar with resistance training in general, and they have a consistent record of resistance training. So in that manuscript, we investigated the effects of low RR training. So by that meaning just completing sets near volitional failure versus high RR training. And in our world is just, leaving a couple reps in the tank for each set. And how the differences in those training paradigms obviously led to either improvements in strength, muscle hypertrophy, and those sort of measurements. In that paper, we reported that there were essentially the same appreciation of strength following the training paradigm. So it didn't matter whether groups were in the low or high RR training group. They seemed to similarly improve lift specific strength. And it's also important to note that these individuals followed a full training paradigm, but the low and high RR training intervention was only conducted in the three main powerlifting exercises. So this is either the squat, the deadlift, or the bench press. So based off of the prescribed intensity load, the low RR group will complete each of those like prescribed sets to near volitional failure. And we identify that as leaving an RR between 0 and 1. And then we coin this as, volitional failure because, we don't have any objective measures to really see how fatigued the muscles are and those sort of thing. And then it will be the opposite for the high RR group. The numbers we reported there was around 4 to 6. So individuals on average in the high RR group left 4 to 6 reps in the tank, roughly. And based off those paradigms, both groups similarly improved 1 rep max strength in regards to bench press, deadlift, and squat. Also, they similarly improved their isometric knee extensor torque output as well. So that's in regards to the practical strength gains. In regards to muscle morphology, so muscle size, we also saw really no differences. So no differences between the groups, which was a little surprising, and that may be attributed to just a relatively short training period. I believe we had 5 weeks of progression overload plus a 1 week of detraining right before the second testing visit. Now, those measurements we saw there was essentially.
Can I ask a question?
Yes.
Do, do you think you would have saw something if you saw a difference there, especially from like the muscle stuff, if you had taken a sample or a measurement prior to the week of detraining?
That is a great question. In regards to the muscle hypertrophy, right? If we saw any difference there, yeah, sure. That's a possibility for sure. And I think our rationale there was to make sure that these individuals weren't tapped out for our post testing session. Um, so of course that's one of those things where you kind of look back and be like, yeah, well, we could have done that, and maybe parse out some of the muscle morphology. nature as
Well,
well.
research is all about picking and choosing, right?
That's all
Because
it is.
you
That's
you
all it
can't
is.
have everything. It's like, give and take, uh, sort of thing. So yeah, I get that.
Yeah, yeah. But on the neuromuscular side, like we also saw essentially the same thing. Like we observed no differences in the rate of motor unit recruitment during fatigue. And now this is important, and this will kind of, touch on our later topics. Whenever you bring a muscle to fatigue during a working set or even during a prolonged contraction, the brain has to do something to compensate for the increased demand. And in our paper, we focus on the additional recruitment of individual motor units. And this is also exemplified through just visualizing the universal EMG signal as a muscle reaches that capacity, uh, that fatigue capacity, that signal will increase. And that increase in the signal just corresponds to the affinity of the CNS, the central nervous system, to recruit additional motor units to increase that demand. The the idea we wanted to parse out is the rate of that increase. And by rate is, can you modulate that rate based off of the specific training paradigm that you choose to implement, right? So in the practical setting, um, the general thought is if you bring your muscle to near volitional failure, you may be like having more work, and we could have a discussion about training volume sort of things. And it was in our reporting, it was relatively matched, so there was no significant differences in training volume between the group, which is important because I feel like training volume dictates pretty much everything in regards to just strength outcomes and muscle hypertrophy outcomes. But here, the training volumes were matched. Now, the issue is if you consistently train to near volitional failure, are you able to augment the time in which you're able to recruit additional motor units as your muscle reaches fatigue? And based off of our study, the data doesn't suggest that you're able to modulate that rate of additional motor unit recruitment. So by and large, that is just driven, at least how we interpret it in the paper, as just the fatigue status of that muscle. So,
No, that's an interesting question because you're essentially asking, is that component trainable, right?
right, right.
Yeah. Okay. Yeah, that's super interesting. Is there much work in that specific area?
Uh, no, that's partly the reason why we did it. But when you get into neuromuscular physiology, more specifically motor unit physiology, uh, especially related to this context, there's two main components, which is motor unit recruitment and motor unit firing rates. Now, if you survey the literature, the the adaptations of motor unit firing rates following resistance training paradigms are often mixed. And we can get into that a little later if you want, which is, but because of the mixed nature of the motor unit firing rates, our group decided to really focus on the recruitment piece first. Um, so naturally, now that we have this out, parsing out the details related to motor unit firings will be the next logical step. But the question is how can we do that? Because there are multiple ways that you can quantify motor unit firing rates.
Yeah, and that's when you get into the super technical stuff
Right,
of
right, right,
yeah,
right.
yeah.
Yeah.
My extents my extensive experience with EMG is slapping a couple electrodes on, do some bicep curls for a biomechanics lab I taught during my master's. But
Right.
yeah, it's that whole EMG stuff. It gets pretty technical.
Of course. Yeah, it's a beast. It's a beast, man. Like I didn't realize how technical it got until I got into it. And I'm like, oh man, this is it's easy to get lost in the weeds, and I can say even right now in my phase of my PhD program, I'm definitely in the weeds, right? So I'm happy to kind of step back out, and I'm like, oh yeah, this is why I'm doing this.
For sure, for sure. Um, let's maybe take a little bit of a step back. And so you're talking about studying, neuromuscular physiology or neuromuscular science. But why don't you just give like a little bit of a description of like what do we mean by that? And then how is that relevant to say exercise or muscle action or performance and or health?
Right, right. So in my perspective, the term neuromuscular is like an umbrella term, right? Uh, for me, I really like to investigate the central nervous system's contribution to how we essentially gain muscle strength, how we express muscle strength. That's my particular niche. Uh, and even with that, my approach is definitely more from a top down approach. So by that is a lot of the interventions that I may employ, even some of the investigatory tools that we choose to employ. Transcranial magnetic stimulation is one of them. Is we deliver the electrical impulses to the brain, so that way we're able to see how effective the CNS is able to relay that signal to the peripheral target muscle. I've seen the term neuromuscular used uh, from more peripheral mechanisms, right? So just, slapping electrodes onto the surface of a particular muscle, and then um, you activate the muscle peripherally, and then you could use EMG to kind of quantify the activation there. Uh, Tensiomyography is a prime example of that, right? So there's a lot of different ways, you can coin neuromuscular in nature. But for me, I'm more my affinity is to really investigate, whatever is going on to the brain, and then extrapolating that corticospinal tract and how we can potentially improve that the relation of those signals, if that makes sense. That is my interest area, and something I believe can be very beneficial to particular populations.
Right, right, right. Okay, so let me ask you about fatigue then. So let's say within the context of heavy resistance training set, right? Uh, Getting to the point of fatigue, where and how is the locale of fatigue in that particular activity? And maybe comparing that to, is it the bottleneck up in the CNS? Is it peripheral? Is it metabolic? How do you
Right.
think about all of those things? And of course, depending on the activity, depending on the performance, it's going to be different, right? If you're talking endurance, it is very different. But let's
Right.
say within the context of like a heavy lift, like, full true 1RM, you ain't
Right.
getting anything else out of that muscle.
Right. Right.
Like, how do you think about fatigue?
Yeah. Yeah. I think to step back, I mean, fatigue is a nice combination of all those factors that you just explained. So like, my perspective in fatigue, uh, especially for this podcast, would be from like a bottom down approach, and more particularly how the brain will, recruit motor units and modulate the motor unit behavior in order to uh, complete a particular lift. So in this particular question, like a heavy set, let's consider a 1 rep max, for example. If you're okay with that example, once the individual engages in that 1 rep max, you need all of your motor unit stores. Like you need everything. So with that, as soon as you begin that maximal muscle contraction, the brain is going to recruit everything it possibly can, right? So it's a spectrum of uh, motor units across the active motor unit pool. And we can categorize this as lower threshold motor units versus higher threshold motor units. And to give a simple explanation there, for your max efforts, you will be recruiting your higher threshold motor units earlier. Like you need those higher threshold motor units because they have the most functional capacity from a strength perspective. That means that each of these high threshold motor units are innervating your larger muscle fibers, either larger or they're innervating a lot of them. That's how we categorize higher threshold motor units. So typically there in a one repetition maximum, for example, those will turn on instantaneously. And then once the activation uh, is complete, and I say once, but all this occurs pretty much at the same time, the firing rates of the motor units that you're activating will increase, right? So exercise physiology 101, the all or nothing principle, right? Once you turn on a motor unit or once there's a particular threshold in which is reached upon, that motor unit is going to turn on, right? So the question is, okay, well, how often does that motor unit turn on? As you approach fatigue, the rate in which you activate those motor units will increase until it literally can't increase anymore, right? So this is how we see it. Now, if we're talking about like low RR training at relatively low intensities, the rate of activation as well as the rate of the increase in the motor unit firing rates, they occur, let's say, like I like to coin it, simultaneously. At least in my survey of the literature, there's no standardized way in which the central nervous system will either increase the firing rates or increase the motor unit, recruitment or activation, if that makes sense. So with that being said, let's say you're lifting 25 to 30% of your 1RM, and then you do this over and over and over again. Your first couple sets, by and large, your lower threshold motor units are engaged. But as you reach fatigue, you need more juice, right? So now the CNS is like, okay, well, let's recruit higher threshold motor units, while also let's begin to increase the firing rates of the lower threshold motor units. So that's kind of happening, I'll say, simultaneously. And then eventually, once you're kind of tapped out of the stores, the firing rates across the entire motor unit will begin to increase as well. So as you mentioned, like these characteristics are very specific in nature, right? Whether you're performing it or performing resistance training in low loads versus high loads, whether you're approaching fatigue or not, even the different populations, like all those things play a role in how the CNS will, recruit and modulate the firing behavior of the included motor units.
That's really nice. That's a really nice description. And then this also relates to that data that you were talking about earlier,
Yep.
whereas that rate of firing or in the rate of increased activation of motor units does not seem to change with training.
Right.
Yeah. Okay. Cool. No, that was good. So with that, you mentioned lower threshold motor units and higher threshold motor units, and just to make explicit, motor unit being skeletal muscle fibers, so the cell, and then the alpha motor neuron that innervates it. Do you do much work or consideration, or how do you deal with fiber types, and where does that come into play? Because, if you're looking at some of the classic textbooks, and, even, a lot of the textbooks now, it's a little bit, we'll say, incomplete in terms of how fiber types are discussed, right? It's usually described as you got a type 1, you got a type 2A, and then type 2X. But, as we know that there's a little bit more to that with things like hybrid fiber types and misclassification of fiber types from older research, just because of the tools that were being used weren't sensitive enough. But how do you think about fiber types? Do you deal much with them in terms of your research, and then maybe even from like taking your work and then putting that application? What's your sort of perspective when considering fiber types?
Yeah. I haven't done that work myself, but that work has been addressed. Not saying that, more work needs to be done, but that work has actually been addressed. And I can name drop some investigators, labs that has done the work. Uh, Dr. DeFreitas, for one, has done some motor unit analysis with uh, muscle fiber typing. Um, Even Dr. Roberts has contributed to this sort of work with his work with involving muscle biopsies, right? So this work has been done, and from my interpretation, uh, going back to like lower threshold motor units, these are typically more so on the spectrum of your type 1 muscle fiber types. And conversely, your higher threshold motor units are, or maybe best reflective as your type 2. Now, I don't know specifically related to type 2A, type 2B, type 2X sort of things, but typically your higher threshold motor units will correspond mostly with your type 2 fibers.
Yeah. Okay. Yeah. So I was taking a look at a little bit of your work, and there were at least two papers that particularly caught my eye just because I thought they were interesting. Was the imagery stuff, right? To be honest with you, I skimmed it, right? But from what I understand, you did some imagery intervention with some subjects, and was it detraining or immobilization or something like that? But you saw that that imagery actually did cause some actual functional changes. Yeah. So you want to speak to that?
Yeah. And this isn't like I didn't lead this work, and you may be referring to Dr. Kylie Harmon's work, who's now at Syracuse. And if I'm being honest with you, I'm uh I'm using that paradigm, at least part of it, during my dissertation process. There's a wealth of evidence now that action observation and mental imagery protocols can influence muscle strength, or at least the attenuation of strength. Let's say that's what we published um, in that paper. But just to give you some context there, the and this is my perspective, the action observation and mental imagery protocol is really extrapolating out the brain's role in regards to the intent of muscle activation. Um, I remember back in my training days, like a lot of the coaches, whenever we're doing Olympic lifts or we're doing just regular barbell training, if you want that uh, I'll say that practical carryover into the court or to the field, the way you train is very important. So the intent in which you train is usually takes a back seat, I'd say. And I'm setting this up to say individuals who train heavy and who train fast, and by fast is like you attack the weight. It doesn't matter, what intensity you're engaging in, just that intent to attack the weight. So don't slowly ramp up. Give it all you have as soon as possible. And that intent seems to have a nice carryover in how the brain, recruits these higher threshold motor units. So in that paper, the mental imagery, the videos that the participants were were asked to see, these contractions were high velocity, forceful contractions. So it was reinforcing that concept of, turning on you, turning on your motor units as quickly as fast as possible, and you know trying to recruit as much as fast as possible. I know one of Dr. Harmon's work, she did an acute study. So she brought in participants, and this was older adults, which is important. Uh, and before the intervention, she took isometric measures of a particular hand muscle, and she also did some TMS to kind of characterize the corticospinal characteristics. Uh, After she did that, she asked individuals to watch just a 20-minute video of high force contractions. So again, these are high force. These individuals are not moving their peripheral muscles at all. They're just watching. And what she found was an actual attenuation of strength. And this is very important because you can extrapolate this to some immobilization work, and we've done that in our lab as well. And there's other work that has been done really the past 10 to 15 years that has shown a significant attenuation of strength following immobilization whenever you engage in this action observation mental imagery protocol, which is fascinating. And for me, um, how I digest that is whenever a limb is immobilized, you expect to see decreases in muscle hypertrophy if you're not adding any mechanical tension to that muscle, that muscle will shrink. But just the intent of watching does something to that pathway to attenuate the loss of strength, which is fascinating. Um, I can't remember off the top of my head if like a study has been done if individuals were watching high force contractions versus, let's say, lazy contractions or contractions that's not really priming the CNS to really engage in that activation of those high threshold motor units. Uh, but like I will say, the type of mental imagery is very important and is very intentional in our work.
Right. Yeah, I think that's super interesting. And then, like you were mentioning, like the potential therapeutic sort of
Right.
application, right? Um, I was on a paper recently that it was resistance training uh, in the heat, in hot environment, resistance training, normal temperature environment, and then just heat stress in general with no resistance exercise. And it was just an acute study. We looked at some markers of mTOR, not
Right.
protein synthesis itself, but mTOR and some of the downstream targets and heat
Right.
shock proteins and things like that. And what we saw was the heat stress by itself with no resistance training increased some mTOR signaling,
Mm.
which that's not to say if you want to get jacked, go in the sauna. Like
Right. Right. Right.
we got lived experience to show that that's not the case. I wish it were the case, but one of the thoughts that I had was if that potentially could have some sort of offsetting effect for individuals that are in an immobilized state or a detraining state where they can resistance train, but you're getting some sort of anabolic mTOR signal. Obviously, there's more that would need to be sort of parsed out with that in terms of like, is that actually related to my myofibrillar protein synthesis? But you speaking about this imagery stuff and the attenuation of strength loss sort of makes me think it'd be interesting if you combined some of that imagery stuff with some heat exposure and see what sort of effects that might have in an immobilization setting.
Oh yeah, no doubt, no doubt. And even like I know recently there's a preprint now from Dr. Roberts' group that they have done some immobilization work, and they have included some of the wet lab analysis. Um, and like I encourage your audience to kind of read that paper. And it's the potential for this line of research is vast, because these are things that we just don't know. Typically, whenever you employ these investigations, the intervention by and large is designed to improve, muscle hypertrophy, and you kind of get those markers to reflect that. But now, kind of moving away and kind of seeing to which extent that other variables can influence muscle strength outside of resistance training, or even some um, you know nutritional interventions, those sort of thing. How does that uh, influence our capacity to generate strength? And I preface this all to say, like, you know, resistance training is definitely the gold standard. Like, there's nothing that beats resistance training, but to which extent that other interventions uh, can either attenuate or maybe like acutely or chronically improve strength profiles in general is definitely an area that I see kind of growing in the next 5 to 10 years.
For sure, for sure. Yeah, it's interesting because I think a lot of us sort of get into the field of exercise science from like a performance standpoint or a sports standpoint, or like a fitness standpoint. But I think that the more you get into it and sort of understand more of the physiology and read more of the research, and then sort of broaden your horizons of beyond. I mean, because a lot of us like, okay, what do I need to do? Right? I want to build muscle. I want to get stronger. I want to get faster. How do I train? How do I eat? How do I recover? Right? And when you get into that, and then you sort of get beyond your own personal interest,
Right.
which is for sure important, right? Right? Because you want to know what to do.
Exactly.
Uh, you start to see all of the other implications and
Right.
all the other contexts and all the other settings and all the different populations, that some of the things that you may be doing may be beneficial, but in a different way
Right.
for different types of people,
Right.
right? Especially going into like the therapeutic standpoint, or like the health standpoint, like your shirt. You know what I mean? I think a lot of people, just think going to the weight room and lifting weights is for the bros and the bro tanks and yoga pants and stuff like that. And, it is, but it's not just. It's not just. And one thing that, is really poignant for me is, I work with older adults right now. And man, we do strength training every time I see them. Because from a functional standpoint, aside from the cardiometabolic stuff, which is huge, but from a functional standpoint, man, you can just do stuff, And a lot of my clients have been working with, multiple years, 4 or 5 years. I tell them, it's like, if you think about someone who was your age when you started at the same start point, and 4 or 5 years go by, if you look at where they are at now, it's like this. But if you look at where you are now, it's like this. You're just doing more. You feel better. You got more energy. You can move. And then, yeah, from the cardiometabolic standpoint, like, you cut your blood pressure medication down. Your A1C is better. And so I think that sure is super apropos of strength training, is healthcare.
Man, Kurt, let me tell you, the amount of compliments I have, or I've had from this shirt, just traveling the country, has been insane. And this is a testament to my mentor, Dr. Stock. This is a phrase that he's coined, and even how he put it on like a black t-shirt is it's nothing flashy. Like, this is the message, this is what we believe, and there's an ample amount of data to support this this phrase. So, going to your point, we're now doing a lot of work in older adults as well, and and we're putting them through extensive, resistance training programs and protocols. And, again, this is like a testament to my mentor, Dr. Stock. But part of the reason why him and our lab has delved more into this work is to really serve the community. As you mentioned, like, we bring these individuals in, and from a functionality standpoint, how much they get from even participating in the study, uh, like they feel better, they move better, they have more energy, they're able to do more things. You can't really quantify that as far as a research initiative to serve the community. And then on top of that, we're getting interesting data related to either neuromuscular or even ultrasound metrics. So you hit it like on the head for sure. And there's data to suggest even in sarcopenic individuals, it's the loss of muscle strength, not muscle mass necessarily, that kind of dictates the deficits in functionality as you age. So the focus here on muscle strength in and of itself, not just to look good in the t-shirt per se, but the data has shown this time and time again. The stronger you are as you get older, the better life you will live. You know what I mean? There's really no other way around it.
Yeah. It's interesting because it's the muscle strength as well as, VO2 max.
Right.
Two super easy, super simple
Right.
measurements that you could take. And, we do them in our undergrad labs,
Right.
every day, especially muscle strength. That's very easy. But, these two functional measures are better than any sort of genetic test or like biological clock test that you can do in terms of assessing your health and even like your mortality risk.
Right. Yeah, I mean, you're exactly right. And I think it's a good transition to my dissertation work. I will be investigating particular interventions, which it will be neuronal in nature, but our main outcome measure is maximum hand grip force among older adults. And there's longitudinal data that explicitly shows how hand grip force measurements are associated with a whole host of functional, cognitive, and mortality metrics in general. So in my dissertation, I wanted to make sure, and I can say we, because of course it takes a team. We wanted to make sure that we're able to analyze these neuromuscular profiles in like a practical, easy to administer strength test. Because as you mentioned, the the practicality of these metrics is very important. And I can say this is a relative limitation of the neuromuscular work in general, at least the motor unit physiology side, is the way we characterize these motor units are not reflective of how these individuals actually contract their muscles. Like we really have to employ this controlled activation scheme in order to extrapolate those motor unit characteristics. So for me, in my dissertation work, we want to make sure that we keep the external validity of the strength assessment as potent as possible, while also trying to then characterize neuromuscular metrics from that test.
That's a really good point, man. Our field in general is applied, right? Because the ultimate idea is to apply it into populations. But, sometimes some research it's very, can be distant from the application.
Right.
So I think research that can tie, the science, physiology, mechanistic stuff, like what's going on under the hood, with the world application, like that's the best of both worlds.
Right. I mean, individuals who can do that, you're hitting pay dirt, in my opinion. and this is really inside the field, right? Like I tell students all the time, whenever you read a like a research paper or study, the title is nice, and like the title is meant to kind of grab your attention and make sure you understand the take home message. But make sure you do your due diligence in uh, knowing the sample population that was included. If you're privy to that stuff, knowing some of the tools that were administered in order to justify their claims, because there can be 4 or 5 different tools that assess essentially the same thing, right? So having that appropriate context whenever you read these papers are very important. And then once you do that, you realize um, how to digest the literature, right? Um, and it takes time, of course, but like I always tell students, whenever like a popular, you know, new study that grabs attention, it's like, hey, like the flashy titles are nice, but also do your due diligence because, um, like at least in our world, man, specificity is king. It's not only how you do it, but who's doing it, um, the intent to which they're doing it, and even the intent of the researchers in large, right? Like I've experienced this. I have my blinders on when like I'm trying to create a particular study, and once you put your those blinders on, it's kind of hard for you to kind of see those ancillary components until it's too late, and then kind of when you remove them, and you're like, man, I should have also included that, or maybe considered that particular perspective. And as you mentioned earlier, like it's research is give and take, and us as researchers, we really have to do our due diligence in expressing our results in a way that also addresses the nuance and the specific contextual characteristics, uh, which is very important. And even with my students, I make sure that I emphasize that, but also knowing that it may take them some time as well.
Yeah, no, that's right on. It's if you're a young student, undergrad, or maybe going into a master's or something, uh, you might have an idea of research. You might have an idea of what it is to do a study, but it's not until you're in the trenches or on the drawing board or facing your committee during your defense that's like, okay, it's a whole other thing. I teach a research methods class for our first year master's students, and I mentor master's students as well. And one of the big lessons is, hey, you can't answer everything with one study. Like you might have this very, very interesting question, but practically speaking, it is unanswerable in this way, right? You can answer an aspect of it, an element of it that contributes to the larger question. But, like we've been saying, you got to kind of pick and choose in terms of what specific research question you want to answer. And you got to be patient. You know what I mean? You got to be willing to compromise. And you got to be willing to, not trying to win a Nobel Prize with your master's thesis. You know what I mean? And I think that's a real big, thing to consider for students that are thinking about going into research is, a student might get discouraged, right? It's like, oh, my advisor or my professor, they don't believe in me. They don't think it's a good study. And, more often than not, it's not that. It's more of, it's not feasible. It's not practical. And in order for you to do a good quality study in the thing that you are interested in, you got to dial it back a little bit, skim it down, scale it down, and get more specific.
Right, right. Yeah. What you just said has been, pretty much the highlight of not only my approach to my PhD experience at large, but even my mentor's approach now, him like reflecting back and realizing, man, these grandioso studies, it's almost like you're addressing a lot, but how the depth in which you can kind of go is compromised. And I think by and large through that, how he's mentored me is, um, especially in this neuromuscular game, like understand the tools that you're using. Make sure you build the skill sets and understand like intimately the limitations that your tools have. So there, whenever you employ them in whatever context you decide to do, you you have an understanding of how far you can take these claims. Uh, and yeah, like um, students who are interested in research, it's like a learning curve for them to really understand. Okay, this is the pace of research. This is how it is, and like you've seen these figures of like this is the world, and your PhD contributions is like this one little small little hump. But like I think the PhD experience is really teaching you like how to think. It's teaching you how to like approach the problem. And I'm thankful, like reflecting back, that like a lot of my work has been methodological in nature because inherently if there's methods that like are not easily reproduced, then the ability to get concrete answers to particular questions is automatically compromised. So it's almost like a twofold thing for me. Like I'm really understanding, okay, this is why we do this. And then down the line, once I, kind of identify a nice niche area for me to investigate, I have a nice foundation in regards to the tools that I'm using. Um, so like I've also kind of noticed that like individuals in a PhD, they really like to focus on the problem, but not necessarily like the tools that they use to solve the problem, and uh, I also always say this, man. No research experience, no PhD experience is built the same. Like you really can't compare. You truly cannot compare these approaches. So my approach has been, more so really investigating the tools that I'm using, so that way I can apply them anywhere, but I'm confident in the claims I'm able to make off of those assessments.
Yeah, I think that's a big learning thing too. Of specifically, you mentioned what conclusions you can make off, say, a research study or your data. Uh, you don't want to get into a situation where you're defending your thesis or your dissertation, and you make some conclusion about your data, and one of your committee members say, "Wait, how was
Right.
that?"
Right. Oh yeah, yeah.
Yeah,
Yeah. They lead you to the shadow of the valley of death is what I call that, man. I've been
yeah,
yeah.
yeah. No, definitely. Cool. That I really like that conversation. Uh, I do want to go back to the TMS stuff.
Right.
Uh, it's super interesting. The first time I saw a YouTube video of that, I was like, "What?" So it's interesting. But can you explain what it is and what speaking of knowing your tools, knowing your instruments, what context are you using it for?
Yeah. So the TMS stands for transcranial magnetic stimulation. And in our laboratory, we use it as an investigatory tool. So this is a little different than what you'll see in labs that are using this as an intervention tool, because you can also use it as that. But in our lab, we use it primarily to assess the corticospinal tract. And this is the tract that relays the efferent pathway from the brain to the muscle, in order for the peripheral muscles to ultimately depolarize and engage in that muscle contraction. So that's really all we use it for. We just send that signal down, and then we quantify the activation of the peripheral muscle with surface EMG. So again, just to clarify, we zap the brain, and this is typically along the M1 motor strip, so the primary motor cortex. And um, there's a couple things you have to do in order to find the exact spot. So, you
That was
can.
going to be my next question.
Yep, yeah.
How is it that you find the correct spot? And like how much, centimeter, millimeter over you're activating the right leg,
Yeah,
millimeter over
yeah,
activating the left arm?
right, right. Yeah, so like all of my work has been primarily in the quadriceps. So the knee extensors. So hypothetically, if you want to deliver stimulation to ultimately result in an involuntary contraction of the vasti muscle group. Um, let's say the target area is the right VL. Knowing how the corticospinal tracts decussate, I'll have to deliver an impulse somewhere along the left side of the brain in order to activate the right side of the body. So, how we do it in our lab, it's nice because we don't have access to an MRI system. We don't have the support of like lab engineers that can create these elaborate codes for us to estimate these sort of things. We first find the vortex on an individual scalp, and typically by that we just have landmarks on the the participant scalp. So it's either like we have a line from tragus to tragus, so it's just the ear to ear, and then we have another line from just the between the eyebrows to the occipital protuberance. And then the intersection of that point is what we call the vertex. So there, from an anatomical perspective, roughly, this is where we're able to quantify the rough area of the motor cortex. From then on, we create these grids, and it's 1 by 1 centimeter, and then we do this essentially along the left side of the motor cortex. And then from there, we just systemically test each site until we find the optimal location for uh for TMS measures moving forward. So it's it's a very meticulous process. This process can take anywhere from 20 to 40 to 45 minutes alone just to get the correct spot. But once we find the spot, then we're able to proceed with the TMS protocol. And again, there's a lot of different measures that you can get to quantify active or to quantify corticospinal excitability. The one that has been used commonly in our field is what we call the active motor threshold. And this is a threshold, so an intensity of the TMS pulse that will ultimately evoke a reliable response in that target muscle. So once you quantify that, you can deliver an intervention, and based off of that intervention, you can assess the change in that motor threshold. And I think I said active motor threshold. You can also do TMS or resting measures as well. So we could just say motor threshold. Um, Typically, what you want to see, for increased excitability, for example, is you want the motor threshold to reduce in intensity. So that means hypothetically it takes less of an intensity to invoke the same magnitude of activation in the target muscle. And that is a pretty documented adaptation to resistance training.
Right. That was going to be my follow-up question to that if it related to that. Um, So as you're explaining, how to go about finding the right spots, I was imagining or picturing when we all were learning muscle biopsies. Man, we did so many muscle biopsies on each other to practice. I got my thighs all cut up. But is it one of those things where you all are in the lab and just
Exactly.
zapping?
Yep. Yep. Yeah. And there's a rule of thumb in the lab. Like I had um a former lab mate. He's since graduated. Dr. Ryan Gerst, man. He's the individual that if there's any tool in the lab, he wants to see how far it can go. So the TMS core, the TMS machine and core that we have, it goes from 0 to 100. So for him, he took it upon himself for him to see how it would feel if you deliver the TMS pulse at 100% intensity. And this the sensation of the pulse is not bad. It kind of feels like a tap, but that tap will get increasingly more forceful as you increase the intensity. So for me, I've gone up to 75 or 80, and it's one of those deals where your whole body just uh, it contracts involuntarily, which is pretty cool. It's interesting. I remember like I had this one participant who for whatever reason, like I really had to jack up the intensity. And like, man, it was being on the other side of like delivering the pulse, knowing that like it doesn't hurt them. At least that's what they tell me. But like it's almost like you're kind of shocking them a little bit, and like you're delivering the pain even though you don't want to, and like you kind of see their reaction. It's like, man, I can tell this story. I remember I was like at 85 or 86, and I just wasn't getting the activation that I wanted. And then I'm asking the participant, hey, like, are you good? He's like, yes, it's fine. Um, but I'm like, man, I might have to go out to 100. And I went out to my mentor. I'm like, look, man, I don't know if I'm comfortable really doing that. And then my mentor looked me in my eye. He's like, if the participant's comfortable, you're gonna do it. And I'm like, all right, man, I guess this is I guess
You
this is
signed the
my
informed consent.
yeah. Oh yeah, he good. Yeah. But this is,
Yeah,
oh, man.
it's all fair game.
Right. It's all fair again. But it was like, man, that was I'd say that's my introduction to like human subjects research for sure. Um, and like the participant was tolerating it well. Of course, all this is, um, we employ a fan visit to just make sure that everybody's comfortable, that sort of thing. But that was definitely my welcome to welcome to science moment for sure. Like, as long as the participant's cool, you gotta do what you gotta do to get the data. So.
Right. That reminds me of the man. I can't remember what the specifics were, but I remember like when Psych 101 class they had that experiment. I remember watching like the black and white footage of
Exactly.
like two people in a different room.
Yes. Yes.
One participant, the other guy is on this machine delivering impulses,
Exactly.
and the guy on the other side wasn't getting the impulses, but they're like playing a recording or like
Right.
sounding like it's painful, whatever. And
Oh,
the
yep.
yeah.
Yeah.
Uh,
Exactly.
okay. I think my next question I want to ask you then is, considering your work, what you're doing now, especially moving into older population, right? What sort of things are you hoping to accomplish, not just with this study, but understand and learn related to neuromuscular changes, neuromuscular function, functional changes in older adults? Because,
Right.
like you said, the resistance training is huge in terms of facilitating health and function, especially at older ages. And the neuromuscular component, man, that's like it's not quite the engine. Well, it's the engine and the program, right? It's like the engine and the computer. It's both of those things.
Right. Right.
So what are you looking at, or what are you looking into moving forward, and really getting at with your work?
Yeah, yeah. We brought in a couple new PIs in the lab that really specialize in, taking participants' MRI images and really characterizing the morphology of the brain itself, the characteristics of the brain itself. And I remember going to a couple workshops in like neuromodulation techniques. So these techniques are primarily administered to induce neuroplasticity, right? So the changing in the way your neurons fire uh, to complete a particular task. So I remember a couple presenters there. They presented on how the brain changes as you age, and I was fascinated by the fact that the motor cortex, at least the integrity from a morphology perspective, is pretty robust. It doesn't really change much as you age, but areas like the prefrontal cortex, for example, it begins to atrophy, and there's things going on there as you age. And I got this idea of like, well, okay, we know with muscular strength, it's this blend of, we can call it neuronal and peripheral muscular components. There's this interplay here. And I got this idea of like, man, I wonder if we administer some of these neuromodulation techniques in areas that are more prone to atrophy in older adults. And I wonder how that can influence that that relationship in the context of muscular strength in general. So that was the foundation of my dissertation work. Again, like I told you, a lot of my studies in my PhD has been method methodological in nature. So like I'm just trying to figure out the tool that I have and applying that to particular populations. Now that I feel confident there, I'm interested to really extrapolating the importance of the changes in the brain as you age and how that ultimately uh, influences strength outcomes in older adults. So with my dissertation, not only will I employ the action, observation, and mental imagery protocol that we discussed previously, I will also administer uh, what is called a transcranial direct current stimulation. And all that is just I'm placing two electrodes along the prefrontal cortex area of these individuals' brains, and I'm delivering a prolonged subthreshold electrical current. And the goal there is just to excite the underlying neurons along that area of the brain that is more prone to atrophy as you age. And then combining that with the action, observation, and mental imagery, and seeing how that, from an acute perspective, influences maximal hand grip force. And then along with that, of course, we'll include the neuromuscular characteristics from a motor unit perspective, along while keeping that external validity component as potent as possible. So I'm, in a nutshell, I'm really interested in seeing like how far does the rabbit hole go as far as just isolating the neural component of muscle strength as you age.
That's interesting, man. That's real interesting. I always tell people, like, they ask me questions like, man, anything below the neck, I'm okay with. Above the neck is a whole other thing, man. So I commend you on researching that area, because, man, the human brain is the most complicated thing in the universe.
It's complicated. It's so it's a beast, and by no means I don't. I'm actually taking this phrase from somebody else, and I loved it instantly. I don't consider myself like a neuroscientist. I don't consider myself anything related because what they do, I mean, it's you talk about next level type stuff. Like it's on a whole nother level. Uh, at least in my point of view, of course. But you know, within our field, um, investigating more of the simple neuromuscular tools, like I don't see why not. And the tie there, uh, you know, not even in the like adult population is in situations where you know you have to immobilize a limb or you know if an athlete is unable to engage in training for XYZ or even you know talking about recovery, right? Everybody has their capacity where they could really go hard all the time, but in moments where you know you're trying to rest, is there like a small window there that you could still like you know keep your mind sharp or potent while also not having to put that extra mileage on your body as the season goes on and stuff. So these are some of the things that I kind of see my work moving forward, how that can be applied in just like the practical athletic population. But even right now, um, working with older adults, just exploring alternative interventions that they can use in order to either improve or at least maintain muscle force output.
No, absolutely, absolutely. Um, my one of my professors, undergrad professors, and I'm sure every exercise science professor has said this at one point, but the more tools you have in the toolbox, the better.
Right.
You know what I mean? And those tools can change depending on the population or depending on whatever may be going on in an individual's life, like you mentioned, right? Yeah. Oh. Well, hey man, I appreciate this discussion. I definitely learned a lot. Super interesting stuff. Again, I'm not like a neuromuscular dude. I know action potentials, excitation, contraction, coupling, size principle, those sorts of things. But this was definitely interesting, and appreciate your time. But then also, you know, I think you communicated things very, very well, especially for someone like myself that doesn't have a deep understanding of some of these things. Yeah, appreciate that.
Oh no, man, I can't extend my gratitude enough. You know, individuals in my field, especially my position as a PhD candidate, I think science communication, especially given the work that we do, is very important. It's like I didn't really realize this um till recently, rather, if I'm being honest with you, just the amount of information that's out there that you know may be lacking in some nuance and some contextual details. And you know, by and large, the individuals that are dominating this space, at least from the uh, the social media platform, these individuals should be individuals like me in my position, you know, and kind of getting out of that academic bubble and really being out there and embracing opportunities like this to really speak. And even more so, if you're working in an area that is complex, understanding and kind of formulating uh, your talking points in a way that is easily digestible to individuals to understand is very important, and it's really our job to do so. And it's a journey for me that I just started on myself. So again, I really appreciate you for facilitating my journey, and yeah, I can't express my gratitude enough.
Yeah, man, I feel you on that because you know, like you mentioned, getting out of just in the academia or out of the lab or out of the classroom or out of the office. You know, I ain't got no social media. I got a LinkedIn, a ResearchGate.
Right, right.
You know, I don't got an Instagram or a TikTok, and I prefer it that way. You know, I like keeping a low profile and flying under the radar, and you know, don't need all that noise to be frank with you. But so getting to do this was like honestly a big sort of obstacle to overcome. It's like, I'm gonna be out there. Like I'm not gonna be like, just,
Right.
some of those big dudes. I don't want to be those
Right.
guys either. But it's just getting out and that was a big thing for me. But like we said, like I said earlier on, it's important, like you mentioned, and then also like I genuinely enjoy this. Like I enjoy our conversation, talking with you, talking with others. Like we do at conferences, right? In the halls, or like at a post conference happy hour thing, or even if we're talking like with our students come in, after class or office hours, say, hey, I saw this TikTok, or hey, I got a question about this, and like that's really the best part. Because if you go into science, right? If you go into research, if you go into academia, it's because you like the science, right? You like the research. And so like this sort of stuff, talking about it is, for me, the most interesting and enjoyable part. So, from a personal standpoint, I enjoy doing this. And then also, like you mentioned, there's a lot of bad information that masquerades as science or science backed. And, with a lot of things, it might have a grain of truth to it. But, kind of like you were mentioning with the specificity and what you can and can't say about certain data and certain results, some people, a lot of people aren't there. They ain't rigorous about that, right? They take something and overextend it into a context, into an application that it just ain't justified, just ain't warranted. But if you're someone that don't have a background in that area, is like, oh, that, of course, like that sounds good. That's what it is. That's true. It's like us with like every other area of science. If someone with a PhD, MD, or whatever, it tells us something or says something, we're apt to believe it because, we don't know.
Right. Yeah. I mean, you're exactly right. And I can end this with like, one more thing I realized, like everything is, at least in social media, is delivered like, so quickly, like there really is no time to really digest like the nuanced nature of it. But like I think like having more perspective is so important. Like if you're gonna get your your information there, like I would feel better if you have 4 or 5 or 6 people like hitting like the same topic in different areas, as opposed to just putting all your eggs in one basket and listening to one individual for everything type stuff. So like again, man, I commend you, because I don't think we could have enough individuals, especially like related to like the science and how we interpret science, and what this result may mean to me may mean something a little different to this individual. It doesn't mean that we're both right or wrong. And as you know, like in our field, especially when you get your PhD, like there really is no black or white answers per se. You have your data, and it's your job to really, you know, formulate like a nice argument that your data can justify. But like you never really get concrete answers. But your work, regardless, is always pushing the field forward. And I think having more platforms like this, especially with individuals without credentials, because I also think that's very important. Even if like it's starting small or whatever, like that's fine, uh, because we're really adding to the conversation and bringing a new perspective to it. Like as long as there's more perspectives, I don't see anything wrong with that per se. It's the lack of perspective where I get like a little worried down the line. So
Yeah, for sure, for sure. And one other thing, in thinking about some of the stuff that is out there and some of the stuff that is popular or highly watched and followed or whatever, hopefully people that are watching this will be able to discern how careful, or the tone or the demeanor of how we're talking about these things, right? Like you mentioned, it's more questions. You ain't gonna have the ultimate answers or solve everything. But there's way more uncertainty on a lot of things, and speaking with certainty or like complete authority, it might, I don't know, sell better, right? But I think that is an important note, because if we catch someone in after a conference talk or something in the hall or something, and you ask them a question about their research, they may have done 20, 30 years of research on a specific topic, right? Like they're the person.
Right.
When you ask them a question, when you talk to them, like they're always careful, right? They're always talking. Most of the time, someone might start to answer a question with, we don't really quite know, right? Right. Or that's a good question. We're unsure. And this person been studying it for 30 years.
Yeah.
Right. And so I think that is a big thing. And, definitely in the way that you're communicating really expresses that carefulness and that scientific rigor, because it ain't as simple as, do XYZ protocol and you'll live whatever, or increase your strength by 300%, or age backwards, or whatever the case is.
Right.
Yeah.
You're exactly right, man. You're exactly right.
We got some good stuff over here.
Sure.
Yeah. That's what I'm hoping for. Honestly, I ain't got no like aspirations to be big or like it's more about the way I think about it is, and when you're teaching it, of course there can be some exceptions, right? But when you're teaching, like, it ain't about you. It's about the students,
Right.
Right. It's like you are there as an instrument,
right,
to convey that information that you have from your work to them, and there are some people that might have some ego, or might want to make it about them, and in general, I don't really have anyone in particular, so I'm not like throwing shade anywhere, but it's really about your instrument from your past work, that you're there for them to serve them, right? You're more the mediator rather than like, you ain't the show.
Right.
They ain't paying this much money to come watch you perform in front of a classroom. They're there to learn.
Exactly. And even that perspective, like the students should also adopt that perspective too. It's almost like they come in and they expect the professors to put on this show to make it worth their while. And like for me, it's like, look, you guys are paying good money for this, and like there's a huge debate in regards to whether even higher education, because of the cost, even if that is even like a good investment anymore, like outside of like 25, 30 years. So for me, it's like I really take I really take it seriously to make sure that like I meet the students where they are, and not only from a content perspective, like they'll get the content, but I also emphasize, like, at least from an undergraduate perspective, like, man, this piece of paper is not going to guarantee you anything. You know what I mean? Like, I had to learn this the hard way. I've always done well in school, but I didn't really realize this. Once I got out with my bachelor's, I'm like, man, okay, um, like I really I really should have engaged in more like career development, networking sort of activities to set myself up. And like from my experience, a lot of the students that come in, they don't really have that awareness,
right?
And for me, like I make sure that I kind of establish that expectation. I'm like, look, like the goal shouldn't be for you to get an A in this class. Like You can get an A, but like, what does that really do for you at the end of the day? Like, my goal is for you to truly understand these concepts, and then understand like the nuanced nature, understand how you see yourself applying these concepts in these various opportunities, and then going out there and pursuing those opportunities. It's not a situation like, medical school, where you have to
Right.
like perform well, and then that will dictate where you are. Once you get to your bachelor's, like, you're in the real world, and like a lot of it is really based off of the connections that you've had over the time or whatever. So like, I really emphasize it there. Then, once I set that standard, like, then like all the ego, the superficial stuff really goes away, and then now
Yeah.
I could
Yeah.
really, really speak to these students, and they appreciate it, and like for me, I'm not going to teach if I'm not myself, man. And it took a couple of years
Mm-hmm.
to kind of get,
Mm-hmm.
because like, the students can tell whether you're like not authentic, or you're just trying to show it. Like,
Right.
you can tell, you know what I mean?
Yeah.
And like,
Yeah.
for me, it's like, look, I'm not trying to waste your time. But when you come to class, like, the learning aspect is important. Like, we're not here to play school. We could play school all day, it's fine. But like, the learning aspect is really like is the most important thing for me. Like, I don't know if it's the same thing for you. I never had aspirations to be like this grandioso. Like, I never had this grandioso thing. I could really
Right.
care less about
Yeah.
like prestige, the ego, man. I like you can miss me with that, man. And I really, to your point, every time I kind of see it, like an inkling of that, I really shy away from, like, I really shy away from that,
Yeah.
like, I don't like that. But what I realize is, like, you get to respect the students once they really realize that, okay, like, I really understand why he's doing this, you know?
Mm-hmm. Mm-hmm.
So that's what keeps me sane in this space, man. Because like, these last couple of years has been a journey for sure.
Yep. Yep. That means you're doing it right. That means you're doing it right. Uh, yeah. No. That I'm the same way, man. It's like, any inkling of, after a class or something, like ego, or like, oh, I had him, or or that
Right,
was,
right, right,
you know what I mean? It's like, man, this shit ain't about you.
right, right.
Right?
Exactly.
That means you did your job. If
Right,
they enjoyed
right.
it, that means you did your job, and that's it.
That's it.
Yeah. Yeah, yeah, yeah.
Exactly, man.
Yeah. And to your point, you know, uh, that don't mean not being yourself. It does mean being yourself, and uh, you know, not, just being real with students, and
Of course,
obviously, like, being professional and making sure you're maintaining that
of course, of course,
professional
of
type
course.
thing. Because some students might just walk in and be like, oh, you don't look like a typical professor. He don't talk like a typical professor. I'm gonna, just
Right,
be a little bit lax. Like, I mean, we could be cool, but we still got a job to do.
right,
You know
right,
what I mean?
right. And like, I feel like that's just like, it just kind of goes back to like my athletic journey, man. Like, I had coaches that were like no nonsense. It's either this way or the highway. And I had other coaches that, like, they were cool with you, but you also know when it's time to work, it's time to work. And like,
Yeah.
I realized, like, okay, like, in order for you to do that, like, I mean, you have to set the precedent early. You know what I mean? And and stick to your guns, of course. But like, that expectation, that at that level, has to be set early, and then students who will rock, and students who don't, it is what it is, and you just keep it moving.
Yeah.
But like, the intent, for me, is important. And I'm not gonna lie, man. It took me a couple years, man. Like, the first time I was teaching, like, I don't know if if you can recall back to like your first time really, really teaching. But for me, it was always like, man, I got to be on my P's and Q's. I got to make sure like the content's right. And then as you teach over and over and over again, like, you kind of understand, okay, like, uh the content's here, but the delivery and trial and error and all that stuff. So
Right.
I, I can say now, like, the type of temperament I have is I'm still formulating it, of course, but like I feel confident that I'm able to, you know, at least set that standard, but also be very approachable
Right.
with my students. It's tough. Like, UCF, we have like I have, class sizes 70, 75, spring, and fall. And like as a PhD student, of course, like that's essentially how I'm supported. Like I'm on a teaching line
Right.
essentially.
Right.
Like, you know, when you got to do research and all that stuff, like it's a balance that you have to strike. And for me, it's like at least in this setting, other settings may change, but at least for me, like I had to adopt a way to uh parse out the students that are just here just for the piece of paper and they don't want to engage, versus the students that take the initiative. They'd be like,
Yeah.
okay, like let me make sure I put in like I put in more time with you, whether that's office hours or after labs, we come in, chop it up type stuff. Um, so like yeah, like I also realize that like a lot of individuals can't do that, and it's a balance. So
Yeah. Yeah. Yeah, no, I definitely agree. And, I think, something like this kind of works towards that end of education, right?
right,
Talking about the science, talking about the field, um, and also in like a real way and in a passionate way. Like I said,
right,
you know, for many students, thinking about science or thinking about research or just thinking about like whatever area of study might be I would say foreign, but like a distant thing, right? Like it's not real. It's like it's not
right,
real,
right,
right? It's not accessible. It's like some
right,
abstract thing that you read in a textbook or
right,
something that
right,
your
right,
professors talk about or the research stuff. It's like I know what it is, but I don't really know what it is. And if you
right.
can, talk about things in the classroom and or out of the classroom with students in office hours and lab and stuff like that, and communicate it in like a real way, right? And
No way.
then right, and like we're having a conversation here, like I mentioned, like two guys chopping it up about science, chopping about research. It makes it
Right.
more accessible, right? It makes it more real rather than reading definitions and and reading
I
like
think
some complex scientific paper. Yeah,
it's huge. Like, for me, you could speak on this as well, man. Like I've just noticed like a lack of diversity in general, man, like especially in these United States in regards to like and by diversity, like it's not even like the skin tone, just like the ideology of thought, right? Like typically these PIs will they'll bring in students that that best reflect them so they can work more easily, with that student, which is not a bad thing from a productivity standpoint, but in terms of like introducing different perspectives that may be important, it's kind of tough. And like as you
yeah,
know, have biases everywhere. Like there's like you can't really conduct science with zero bias because we all bring our lived experiences in there. Like there's no escaping it.
hmm hmm
Um, and like for me, I've kind of realized like, you know, like it would be nice to have more diversity of perspectives. Like the empirical data is the empirical data. Like
right, yeah,
objectivity
yeah,
is objectivity.
yeah,
You know what I mean? Like that's not going to change. But like, you know, it's just how one practices medicine, one practices law. Like we're practicing science. Like this is what it is, and like our perspective is by and large informed by our lived experiences. So if we bring in individuals that have like the same lived experiences as you, again, for productivity from an academia perspective, that's great. But if the goal is to really conduct a better science, again, man, like perspective, I think is like it should be at a premium.
yeah,
And like just the delivery and just having individuals kind of see this. It's like, oh, okay, well, if they're talking about like this, maybe I can, maybe I can do a little something into it. You know what I mean? And like,
That's it right there, man. That's it. Yeah, yeah,
so like just the representation of having, certain individuals with a different background speaking, because like I remember writing an essay for uh this LDTP program once. I'm realizing like, yo, there's, if you want to be a hooper, there's a lot of individuals that look like me that's hooping. You know what I mean? Like there, if you want to do something this, that, and the third, like there's a lot of individuals that look like me. But how many individuals are like, yeah, I want to be a professor. Like, man, I want to,
right,
I want to do
right.
research. And is it because of the nature of the work? I mean, yeah, maybe, but I think also with that is just the lack of like diverse representation of how science topics are discussed. You know what I mean? Because
Yeah,
if you see it like that, it's like, okay, shoot, they're talking about it like that. Like, okay, like it just opens up as a possibility. And then maybe those individuals, they'll be more open to seeking out those opportunities, man, because like they're out there,
yeah.
like they really are. I don't think individuals really want to do it because they don't really see like individuals like us just kind of chopping it up in a way that speaks to them more so.
Yeah, no, that's it, man. I that's all right on. I'm with you on all that, especially like the communication standpoint. It like you say, the data are the data, the empirical stuff is empirical stuff, but what could be the barrier is how that's communicated
Yeah,
and how that lands and how that resonates with
right.
different types of people, different types of students. And you know yeah, for some people, for some students, uh there ain't many people that may look like them, sound like them, and that could be a barrier.
Right.
And one of the things that I sort of think about is that, right? Like think about me when I was a student,
Yeah.
and not really seeing people like my people, like where I'm from,
No.
in science, right? In academia.
Yeah.
Not to say that there's zero people,
Right.
but prevalence wise, it's not one of those things. And so when I was coming up, it's like, man, I want to be uh, solid PhD student, want to be a solid PhD, solid professor, solid researcher. Although I'm not doing that much research at my institution, so I don't consider myself like a researcher per se. But yeah, it's one of those things where it's like um, thinking about, I'm not going to try to fit into like what I perceive the field with science to be, but shoot, man, the stuff that we're doing, like our work, like our education, our credentials, the letters, like we are, for lack of a better term, like we are the science now,
Right.
right?
Right.
We are in it, and I think just being us and representing us and representing our communities and the people that we came from, that goes a long way, because there's a lot of students that are like that may be feeling, experiencing the same thing, where they look at science or academia or even just like the field of study, and it sort of feel like foreign to them. But if you can communicate it in a way that like, hey, I know that, like it makes it real.
1,000%. 1,000%. And like that's all it takes. And once you have the spark, then you can like, you can make it through a PhD program, man. You can make it through the rigor. You really can. You know what I mean? Like it's one of those situations where, um, going back to your point, like I know individuals in that position, like it's a thought because it ran through my mind like many times. How many times I would present and like I look at the researchers that I'm citing, like it's obvious. if I'm being honest with you. Uh, and you don't make excuses. You do what you got to do. But it's like, you know, whenever you get there, if I can contribute to like, you know, bringing in more individuals into the space,
Yeah. Yeah.
like I really don't see the downside to that. And then also with that, like, bringing them up to speed with the rigor and all that stuff, like all those things is important. Like uh that's important because you don't get in our positions without really understanding the landscape of academia, how science is generated, and I don't even have to discuss like the funding mechanisms and all those things. Like there's it's I don't want to call it a game, man, but you
Yeah. It's
you,
game like.
it's game like. I'll say it like that. It's definitely game like. I remember like I went to my alma mater at Life University and speaking with the dean, man, it was a conversation of like, right, you're telling me things that I already know. And mind you, these conversations are happening like behind closed doors. You know what I mean? Like these conversations that I'm alluding to it's uh it's happening behind closed doors. So again, going back to your point, even sparking like that thought that okay, like that's pretty cool. Damn, I can do that. You know what I mean? Like that will be enough. Is that proper representation that is sorely lacking in like the science communication uh,
Right.
for sure, sure.
You can be rigorous while still being real.
Right, man, you got to put that on a shirt or something. Yeah, that's exactly what it is. Yeah, like because man, like I'm reading this book now. It's actually like a business book, but it's one of those things where like these leaders are not like this, like these flashy individuals, but they had like a discipline. They had like a set of rules that it exuberated like the particular rigor that they have. But even if you listen to these podcasts, man, like some of the uh some of the I guess the things that they use in order to communicate their science, man, it's like it may hit with some populations, but it may not hit with other populations. And I think that
Yeah.
that in
Yeah.
and of itself is the key. You know what I mean? Like
Yep.
that in and of
Yep.
itself is like that's the hook in and of itself, you know? So like what you're doing, man, and like your philosophy and like uh your vision, that in and of itself, like I commend you because like it takes a lot of work, but it's eventually, you know, this podcast may be responsible for like this new crop of researchers in the space that's motivated, that's that's rigorous, and then individuals will take them incredibly serious, and that will just kind of bring in more individuals in the space, man. And this field is relatively young, right? I mean, compared
Yeah.
to
Yeah.
like your other more hard sciences. So I think now more than ever, like now more than ever is the time. If I'm being honest with you, like I'll write my essays like the individuals in the NBA who are like who's African American or this down and third is this percent, but the scientists or the sports scientists that are serving them is not really reflective of that.
Right. Right. Right.
What we know about science, it's like, well, if you ask one individual, they may say, oh, well, it's the data, the data. It's like, I mean, yes, but like at the same time, like again, perspective is everything. And once you have those blinders on based on your lived experiences, like there's things you may not even think about that,
Yep.
that may be the key. Uh, and you don't really know because science is science. You can't address everything. And like the best scientists, as you mentioned, they really understand their perspective. They understand the limitations of their biases and 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 where they come from. So yeah, man. Like I said, huge kudos to you, man. And anything I can do to contribute to the vision, man, I'm all for it.
For sure, man. I appreciate that. It's funny that you mentioned that because, there's a good amount of podcasts, YouTube stuff that's health related, science, exercise training related type stuff. And, there'd be some good, sometimes, not all of them, there'd be some good information, right? But man, to your point of, man, what's the word? The delivery, the tone. It's like, nah, that don't work for me.
That don't
That don't work for me.
Right.
I listen to it on 2x just to get the content,
right,
just to get through it, because it's like, they looking at a different demographic.
Right.
You know?
Right. And, because of that, there's no like, it's obvious, why there may be like a lack of representation, man, because we're not really tapping into, or rather the things that's out there is not really tapped into, like other particular populations, I'd say,
or things talking about like, these biohack health protocols type stuff. And it's like, damn, how much that costs? It's like that ain't resonating with me. That ain't resonating with my tios.
Right.
Man, turn that off.
Right.
That ain't happening.
Right. Yeah, you're exactly right about that, man. You're exactly right.
Oh yeah, I think that's some good stuff that is relevant, aside from the science and the research, but it's like the science and the research, like living that stuff,
living it,
and and again affecting students, and I think even students or people like listening to this conversation right here is like, oh, okay, there's people out there that they know what it is, right? They went through it, so I think that's that can make an impact, that can be relevant.
For sure. For everything I say, like, I mean, it's not a secret. Individuals who know me, like they know. And it's about time, so like I commend again, like your initiative, your the reason why, the audience that you're pitching this to, man, I think it's great.
Well, appreciate that, man, and appreciate your help in that. So we'll have to do it again because like I said, I enjoy this conversation. So.
Oh, for sure, man. Yeah, anytime, man. Anytime you can hit my line.
All right, then, man. Again, appreciate it.
Sure.
Best of luck. Let me know how we'll be in contact. But good luck with the dissertation. Getting in the trenches.
Yes, sir. I'll be MIA locked in, and hopefully, whatever comes out, and knock it out and move forward.
For sure, man. And we'll talk about it.
Sounds good, my man. I appreciate you.
All right, then, man. All right. Peace out.
Peace.